Saturn's rings are not solid. They are not even close to solid. They are billions of individual chunks of ice and rock, some the size of a grain of sand, some the size of a house, all orbiting at speeds over 70,000 kilometers per hour. And right now, those rings are dying. Saturn is pulling them inward at a rate that will erase them completely in about 100 million years. That sounds like forever, but on a cosmic timescale, that is tomorrow morning. Here is what that means for you. If you somehow found yourself floating inside that ring system as it collapsed, you would not just die. You would be unmade by physics so precise and so merciless that it borders on beautiful. And understanding exactly how that happens reveals something deeply weird about gravity, motion, and the nature of orbits that almost nobody talks about. Let us start with the thing that kills you first. It is not the ice chunks. It is not the cold. It is the gradient. Imagine gravity as a hand pulling you toward Saturn. Now imagine that hand pulling your feet slightly harder than your head because your feet are a few meters closer to the planet. That difference in gravitational pull across the length of your body is called a tidal force. Near Earth, this difference across your body is so tiny you never feel it. But inside a planetary ring system during collapse, you are operating in a zone where orbital mechanics become personal. The tidal force does not just stretch you slightly. At certain altitudes within the rings, it would stretch your body like taffy before you had time to register any pain. This is not science fiction. This is the same force that defines the Roche limit. The Roche limit is the distance from a planet inside which tidal forces overcome the self-gravity of a smaller object. Saturn's Roche limit sits at roughly 87,000 kilometers from its center. The main ring system sits almost entirely within this zone. That is why the rings exist as rings and not as a moon. Any object that wanders too close gets shredded by tidal forces into a billion smaller pieces. You are an object. You have mass. You have a Roche limit too. A human body held together by biological tension and chemical bonds would begin to experience measurable tidal disruption at altitudes well within the ring plane. You would not explode dramatically. You would elongate along the radial axis, feet toward Saturn, head away. Every organ, every bone, every cell would feel a slightly different gravitational acceleration. The difference compounds. The process is called spaghettification. That word was coined for black holes, but the physics applies wherever tidal gradients become extreme enough. If this just rewired how you think about gravity, subscribe right now. We cover the science that textbooks skip because they think it would scare you. It should. Now here is the second layer. Surviving the tidal forces, even hypothetically, puts you inside the most chaotic gravitational pinball machine in the solar system. The ring particles are not just floating there politely. They are colliding constantly. A cubic kilometer of Saturn's B-ring contains roughly one collision every few seconds between particles. Those collisions are mostly gentle, almost elastic, more like powder hitting powder than rocks smashing. But the orbital mechanics surrounding each collision are not gentle at all. Every time a particle changes velocity slightly, it shifts orbits. Orbital mechanics dictates that slowing down causes you to fall to a lower orbit, which actually speeds you up. Speeding up sends you to a higher orbit, which actually slows you down. This feels completely backward, and it is. It is called the Oberth effect in reverse, and it means that inside the rings, cause and effect between speed and position are inverted compared to everyday experience. A fragment of ice tapping you from behind would not push you forward. It would send you into a lower, faster orbit where you spiral closer to Saturn. Faster, lower, hotter, dead. And the collapse makes all of this worse. Saturn's magnetic field interacts with the charged particles in the rings, drawing ionized material down into the upper atmosphere along invisible field lines. Ring rain. It is real. Roughly 10,000 kilograms of ring material rains down into Saturn every single second. As the ring system thins, orbital resonances with Saturn's moons shift. Moons like Mimas and Enceladus act as gravitational shepherds, herding ring particles into lanes. Remove enough material and those resonances destabilize. Gaps open. Lanes collapse. Particles that were in stable orbits for millions of years suddenly find their orbital paths degraded. They spiral inward. If you are in the path of a destabilizing lane, you are caught in a cascade you cannot predict or outrun. Here is what this means for the future. Planetary ring systems are not permanent features of the cosmos. They are temporary. Jupiter's rings are already nearly invisible. Uranus and Neptune have thin, dark rings showing signs of decay. Saturn's rings, the most spectacular in the solar system, are a geological eye blink in time. We exist at a cosmically lucky moment, the only moment in the 4.5 billion-year history of the solar system when Saturn looks like that. Future civilizations, if they exist hundreds of millions of years from now, will look at Saturn and see a plain, ringless gas giant with no hint of what it once was. More unsettling than that, the material in those rings was probably once a moon. A moon the size of a small city that wandered too close, crossed the Roche limit, and was torn apart into the spectacle we see today. That moon is gone forever, converted into ice dust and sunlight scattering. The rings are its obituary. A slow-motion explosion frozen in orbit. You could not survive inside a collapsing ring system. The tidal forces would take you apart before the ice did. The orbital mechanics would betray every instinct you had about motion and speed. And the collapse itself is a reminder that even the most permanent-looking things in the sky are just physics running on a timer. The universe does not maintain beauty for long. Go outside tonight and look up. Saturn is there. The rings are there. Catch them while you can. If you want more of the science that makes reality feel genuinely strange, subscribe and hit the bell. Next video, we cover what happens to time itself near the surface of a neutron star. You are not ready.